class. This class we are going to look at application of logarithms. We have looked at what logarithms are. Now it is high time we see how we do apply logarithm. So just to remind ourselves, we had laws of indices, the first one and the second one. For a multiplication, we had a case where we have a power n times a power n. When we talk about the indices, we are adding the powers of the lower, so a power m plus n. That's what we had. And also for division, if it's a case of a power n divided by a power n, we were subtracting the powers a power m minus n. And we said that the logarithms and the powers are the same thing because they are the indices, powers, logs, all of them are the same thing, just different names. Now, when we have the same basis there, we have got that we add the powers or we subtract when we are multiplying and when we are adding these numbers. So let's have an example here. If we have an example like this, you've been told to multiply 4,192 times 3,078. Now, using logarithms, remember you can write these numbers to the base of 10. That is using now the logarithms. And we create a table here. We have a table. On one side we have numbers, and the other side we have logs. And we write these numbers into standard form so that you can be able to read the logarithms on the table. So 4,192 should be 123.4.192 times 10 power 3. And then 3,078 would be 3.078 times 10 power 3. And then we did the log of 4.192. And look at that one from the table. Is 3. Of course, this is the first one, 3 point. The log are going to read the back side, and then 10 power 3, of course, it's to be 3 point. 4.192. First we need for 4.19. Then we add the additional column for 2, and we get 0.6222. The log of 4.19, then 2 addition there is 2, and we have 0.6224. 0.6224. So that's the log over 4.192 should be first read for 4.19, which is 0.6224, and then get it like that. Then we read for the log over now 3.078. So this is going to be 3 point, the 10 power. That power is actually 3 point that power. Then we read for 3.07, and 3.07 should be 0.4871, and then we add 8, the column there, it should be having 12 to the far edge, and then you get 0.4883. So just as we have said here, whenever you're multiplying, we add the powers. Remember, these logs are the powers to base of 10. This number, when you write them the base of 10, they're going to be like that. So we have the powers there. So to come very easy, instead of now doing the log multiplication using the logs, it's going to make our work very easy. So you add the 2, you get 4 plus 3, 7, 8 plus 2, 10, 1, 3 plus 8, 11, 1. 7 plus 4, 11, 1, 1. This is 3, 4 plus 3 gets 7 point that. Then you are through with the part in log side. Now we come back to the number. What is this number that is going to give us? 7.1107. So of course, going back one now, this is 10 power 7. Then you read the answer of 0.1107. So 0.1107. So first we read for 0.110, which is 1.288. Then we add 7, which is 2. So you get 10 color 1, 0, 8 plus 1, 9, then 2, 1.290 times 10 power 7. So that's our number, that's our answer when you multiply these two using logarithm. Let's have another example. Example 2b, in this case, and have 2,145 we divide by 560. So when we are doing this division now, if it's long multiplication, is going to give us some headache, but when using the logarithm, it's just a very simple task. So we create a table there. On one side we've got the number, and the other side we have the logarithms. So 2,145, we first write it in standard form, 2.145 times 10 power 3. Then 560 should be 5.6 times 10 power 12. So now we read the log of 2.145, which is going to be, of course, we start the 10 power 3, so it starts with 3 point. So we read the log of 2.145, and this one is going to be 0.3304. Then we add 5 on that additional column there, and it's going to be 10. So you add it to the far edge, and then we are going to get 0.3314. That's the log of 2.145. Then you get the log of 5.6, then times 10 to the power 2 here, so get 2 point, and then 5.6, we have to direct, it's going to be 0.7482. 0.7482. Then we have said the second row of indices was a power m divided by a power m is given by a power m minus n. We had this number, we are dividing them. Their bases now we have written them to the base of 10, that is their logs. And we just subtract the logs. So for division, we subtract the logs. So we get 4 minus 2, 2. 1 minus 8, so we go 1 from that one. We get 11 minus 8, 3. And then we have, this is 2. 12 minus 4, 8. This is 2 again, we go 1 there. Get 12 minus 7, 5. Then 3, we have the remaining 2 there, so 2 minus 2 is 0. So we are through on that side of logs. Now we come back to the number. So this is going to be times 10 power 0, so that is 1. So you're just going to read the answer of 0.5832. So 0.5832, we start with 0.583, that's going to be 3.828. Then additional column there, we add the 2, and they correspond with 2. We add the 2, get 8 plus 2, 10, 1, 3, 8, 3.8, 30 times 10 power 0, which is the same case there for that power, for that. And then so this is 3.830. So when you divide these two, you are going to get 3.830 when we are using the logarithms. So let's have another example. Okay, so for part C, you can have 171.5 cubed out of 36.3 times 26.98. So you can have that as our part C, or example 3. So the same case here, we are using the algorithm to solve that. So we have a table. We have one side is number, then the other side is logs, and we can start with the numerator there. We have write it in standard form. Got 1.715 times 10 power 2, and then this one we are going to read the logs. It's going to be this 10 power 2, also going to be 2 point something. So 1.71. We are going to get it as a first to read that 1.71. So 0.2330. Then 5. We add that column there. We have 12. So we get 0.2342. 0.2342. And then of course we can get here, we have the 1 point, that number we cube it. Now remember we had the law of indices. We had a power m, then power n, this is equals to a power m times n. So whenever you have, because you're working with powers here, so this power 3, we are going to multiply it by 3. And that is power m times n. So you multiply this number by 3. Now because it's a positive number, we multiply it directly. If it were a bar number, the first case here, then we should have first separate the two, then we multiply, and then we add them back. But at the moment, we just multiply it like that, no issue there. So we multiply that number by 3, so we get to get 6.70 26. Let's get 6.7026. Then we come to the denominator there. We have 36.3 raised to standard form, 5.63 times 10 power 1. Then the one is 26.98, 2.698 times 10 power 1 also. So the log of this one is going to be 1 point. For 5.63, we have 0.7505, and then 2.698. We first did for 2.69. 2.69 I have is going to be 0.4289. Then 8, that column of addition, we're going to get 13. We add to the far end there. Then we're going to have the log of 2.698 as 0.4302. 4302. Then we had multiplication in the denominator here. So we are going to add the two logs. So get 5 plus 2, 7, 0 plus 0 is 0, 5 plus 3, 8, 7 plus 4, this is 11, color 1, so we'll be having 1 plus 1, 2 plus 1, 3, 3.1807. So this is the denominator, and this is our numerator here. So this is division sign. So we take what we have in the numerator and what we have in the denominator, we subtract the 2. So we have 6.7062. We subtract the denominator 3.1807. You see what we're going to get. So you have 6 minus 7, go 1 from that one, remaining the 1. 16 minus 7, 9. 1 minus 0 is 1. Go 1 from this one, get 6. 10 minus 8, 2. 6 minus 1, 5. And 6 minus 3, get 3. So we are through with the log sign. Now we come back to the number we get analog of this number. So this is going to be times 10 power 3. That's the first case there. Then we get the analog of 0.5219. Analog of 0.5219. So 0.521, we have 3.319. That is the analog of 0.521. Then we add 9, and that 9 corresponds to 7. We get it to the far end there. So you get 16, 1, 2, 3, and 3.26. This times 10 power 3. Or can multiply by that, and you get 1, 2, 3. You get 3,326 as the solution to that question using the logarithm. So when we are using the logarithm, our work becomes very easy because multiplication and division, when it comes to the logarithm side, we're just adding or subtracting. Let's have an example 4, that is D. We have 0.0075 times 0.8181 over 0.509. So we are using logarithm to solve that. So now you get yourself a table there, one side for number, the other side for logs. So write the number in standard form. You get 1, 2, 3. 7.5 times 10 power negative 3. Then we have 2.8181. So this is going to be 8.181 times 10 power negative 1. And then this one we get 5.09 times 10 power negative 1. We get the log of those numbers. So 7.5 should be 0.8751. So this is going to be bar 3. We start with this number, bar 3.8751. Then for the log of 8.181, it's going to be started with bar 1 there, and then 8.18 you get as a 9.9128. Then 1, we add 1 at the end there, it's corresponding to 1, so you get 9129. 9129. So the numerator, we are adding the 2. So because when you're multiplying the numbers, and then we add the powers or the logs. Get 9 plus 1, 10, 5 plus 1, 6 plus 2, 8, 7 plus 1, 8, and then 9 plus 8, 17, kind 1. So 1 plus minus 1 plus minus 3. Let's make it here. 1 plus minus 3 plus minus 1. So you get this is 1 minus 3 minus 1. And then you get this is 1 minus 3, it's minus 2. Minus 2 minus 1, get minus 3. So the numerator, we have by 3.7882. Then come to the denominator, 0.5909. Let it start form, so going to be 5.09 times 10 power negative 1. So this is going to be by 1 point. Okay, so we got by 1 point 5.09. We get it as 0.7067. 0.7067. We are dividing the numerator and denominator, so we subtract the logs. So we got 1 there from 8 minus 7, 10 minus 7, 3, 7 minus 6, 1, 8 minus 0, 8, 7 minus 0.70, then point minus 3 minus 1, minus 3 minus 1. So minus 4 by minus is plus, so minus 3 plus 1, we get minus 2. So we write there as bar 2. And then we have done like that, you go back to the number. So this is going to be times 10 power negative 2. We did the antron of 0.0813. So 0.0813, we first did 0.081, and that one you're going to get 1.205. Then 3 corresponds with 1, so you add it to the far end there, so you get 602.1. Then times 10 power negative 2. So that's our answer, or we can multiply by that and go backward 2 steps. 1, 2, get 0.01206. So when we multiply those two numbers using logarithm, that's how we can get to the answer very easily. Let's have our last example on this part. So for our last example, we have example A there. We're going to be having 0.09 power 10. We have to evaluate that using logarithm. So we get a table, one side number, the other side the log, like that. Then this number to standard form. So we could be 9.0 times 10 power negative 2. So we did the log of 9, and then of course this is going to be having by 2 point. Log of 9 should be 0.9542. 0.9542. That is the log of 9. So we have got this is power 10. Remember I have said for when we had a case of a power m multiplied by n in the indices. In this case, you are having this was a power m n. So you multiply the powers there. So you're going to multiply this one by 10. And since this number is a bar number, we don't multiply it directly. We first separate the two, the characteristics and the multiplier. So you're going to be having bar 2 plus 0.9542, then you multiply by 10. So bar 2 times 10 you get bar 20 plus 0.9542 times 10 you get 9.542. Then we add these two, minus 20, of course plus 9 is going to be minus 11. So what we're going to be having by 11.542. And then we are through with the log sides. We go back to our number. So this number is going to be times 10 power 11. Times 10 power minus 11. Then we got, now we did the antron of 0.542. Antron of 0.542. We're going to have it as 3.483. 3.483. So that is the value of 0.09 power 10. You get 3.483 times 10 power negative 11. You can go backward 7 steps to get those many zeros there. So that's how we can be able to use the logarithm to deal with the multiplication and the division. Thank you very much for your time.